Hi everybody, this is Mrs. Daly's Math Blog. I just wanted to do a quick video tutorial reviewing the interior angles of a polygon. So I have put these three shapes here on my notepad, and again, excuse me for being a little bit messy. I'm getting used to my bamboo here. So this is a lesson on the interior angles of polygons. And by interior angles, we mean these angles here, here, and here in a triangle. Your interior angles in a square are going to be your 4 inside angles. In a pentagon, there are 5 interior angles, okay? So in talking about the interior angles of polygons, I just want to discuss a couple of things that we can discover from what we already know about triangles. And in this situation, I've got a triangle, a square, and a pentagon, and we're going to fill out some table information and see if we can figure out a formula to derive the sum of all of the interior angles of any polygon. So we've got a triangle here. I'm just going to kind of create a little table, number of sides to each of our shapes. The minimum number of triangles that we can create from our shape, and the sum of the interior angles. Alright, so we've got our number of sides, minimum number of triangles that we can create out of the shape, and the sum of the interior angles. So let's start with this triangle. Triangle. We know that the number of sides is 1, 2, 3. So we've got 3 sides. The minimum number of triangles that we can create from a triangle, well, it's already a triangle, so 1. We don't need to do anything to it to create triangles. And we already know from doing a whole bunch of stuff on triangles that the sum of the interior angles of any triangle is 180 degrees. All the interior angles of a triangle always have to add up to 180 degrees. So what about the square? With the square, we've got how many sides? 4. Minimum number of triangles. Well, I can use just one line to split that square into 2 sections, which makes 2 triangles. So 2 is our minimum number of triangles that we can get out of a square. And if we have 2 triangles, we can add up the angles in each triangle. So 180 plus 180, right? Or 180 times 2, because we have 2 triangles, and that is 360 degrees. What about a pentagon? A pentagon has 5 sides. What's the minimum number of triangles that we can create from a pentagon? This one's a little bit trickier to see, but we can go from, whoops, sorry about that. We can go from our vertex there and make a line down to there. Sorry, my lines aren't super straight with this thing. And a line down to there, and you can see that we have separated this pentagon into 3 triangles. We couldn't do it with just one line. We had to make 2 lines to separate it into 3 triangles. And if you want, you can try and see if you can separate it into 2 or 1, but I believe that the minimum is 3. So 3 triangles is the minimum we can separate a pentagon into. So 3 times 180, because we know that each triangle has 180 degrees. 3 times 180 is 540 degrees. So let's see what we figure out here. If we have an n-gon, what an n-gon is a polygon with n sides. It could be anything. We could say a 20-gon, a 40-gon, a 667-gon, a 5,243,672-gon. And our number of sides is going to be whatever n is. So number of sides is n, and you guys use that a lot. So our number of sides is n. The minimum number of triangles. Well, let's see what we have up here with the triangle. We had 3 sides, and 1 was our minimum number of triangles. With a square, 4 sides, and 2 with the pentagon 5 sides and 3. So if we see what's going on here, we have to take 2 away from the number of sides to get the minimum number of triangles in a triangle. Same with a square. 4 minus 2 is 2. 5 minus 2 is 3. So n minus 2 is going to be our minimum number of triangles. And to get what we have here, the sum of the interior angles, we took this 1 and multiplied it by 180. We took this 2 and multiplied it by 180 to get 360. We took this 3, multiplied it by 180 to get 540. So we can take this n minus 2 in our general form, let's put it in parentheses, and multiply it by 180 to get what the sum of our interior angles are going to be. So let's create a new sheet and just scroll up a little bit here so I have a little more space. If this is our general formula for the sum of interior angles, let's figure out what our interior angles are going to be for let's do a tengon. So if we have a tengon, we can take our formula here, n minus 2 times 180, to figure out what all of the interior angles of this tengon have to add up to. So n would be 10. 10 minus 2 multiplied by 180 equals 8 times 180, which honestly, my brain is not working right now, times 180. Oh, that's not right, I'm sorry. 8 times 180. 1,440 degrees. So this is our answer. If I told you we have a tengon and I want to know what the sum of the interior angles of this tengon is, you would put that into the formula, 10 minus 2 times 180, and you would come up with 1,440 degrees. Well, let's do this backwards. If we know that n minus 2 times 180 is our formula for the sum, say I told you that the sum of the interior angles was 720. I want you to tell me how many sides, or what n is of this polygon. How many sides does this polygon have? So all we need to do is solve for n. So we can distribute that 180 through, and we have 180n minus 360 equals 720. Add that 360 to both sides because we want to get that 180n all by itself. We want the n by itself on that side. So that leaves us with 180n equals 1080, I believe. And then we can divide both sides by 180 to get n all by itself. And that means n equals 1080 divided by 180, which equals 6. So if the sum of our interior angles add up to 720, we know that we're working with a hexagon with 6 sides, hexagon.